All right, gang, let's do lesson 1.4a, triangle sum properties. We're going to go through the practice problems for this lesson. I want to remind you of our goal for the day. And remember, that is to know how to name a triangle and how to find the measure of the interior and exterior angles. After you have that copied, I want you to pause the video, and then we will jump down to the bottom of the page. For these first practice problems, we are going to work on drawing triangles. This is for sure something that you need to make sure that you study this for the test, because I will have you draw some of these triangles, practice with your markings, vocabulary, make sure that you have a good understanding. So let's go through what we ask here. They ask you to draw the triangle described, if possible. Be specific. Use tick marks and or numbers when necessary. So remember that not all of these drawings are necessarily possible, but if they are, you have to have everything marked correctly. So for the first question, they want us to draw a right isosceles triangle. In this case, we have to make it right. That means 90 degrees, and we have to make it isosceles. That's two equal sides. So we're thinking these things right here, 90 degrees. And two equal sides. So when I draw my triangle, I know that 90 degrees has to be like that. And then I go back and I look at my notes, and I know that this guy right here has to be the longest side. We said that opposite the 90 is always the longest. You can't have two longest sides. Longest means that it is the longest. So if we're going to have two equal sides, it would have to be, in this case, the other two sides. And even though I didn't draw it that way to begin with, as long as I have it marked, that's good enough. Right there, I have an example of a right isosceles triangle. All right. The next one, we're going to do letter B here. We need to do an obtuse scalene triangle. So again, we have two things that we're going to be doing here. Obtuse, we have to think more than 90. More than 90, and then when we talk about scalene, we're thinking that we have 0 equal sides. So I have to mark a triangle that has both of those things. So I'm going to draw a triangle that has a really big angle there, and I know that it has to be more than 90. I don't have a mark for 90, but I can put a number in there, and I can put any number that's more than 90 degrees. I don't know, I can put in 100, I could put in 110, I could put in 94, I could put in any number that's more than 90. And then I have to have 0 sides the same. That means that when I mark my tick marks on there, I have to put different tick marks on all of the sides. 1, 2, 3, I can mark one with a 4, and one with a 3 and a 2. It doesn't matter. As long as all of the tick marks are different, I have 0 equal sides. All right, let's jump to the next question, letter C. I need to draw an acute equilateral triangle. So when I draw an acute triangle, I know that I have to draw something that is everything less than 90 degrees. And then when I draw it equilateral, I know I have to have all sides equal. So when I draw this, I'm going to actually start with the equal sides. And then, if you remember, the acute, they all have to add up to 90. And when we did have a triangle, well, I don't know if we talked about this, but if you have a triangle that has 3 equal sides, it turns out that you have 3 equal angles right there. And actually, all of those angles, if you remember, will be 60 degrees each. So it turns out each of those angles there are going to be 60 degrees. All right. The last one, let's jump to letter D here. We're going to do a right acute triangle. So again, when I think of a right acute triangle, I'm thinking of a triangle that has 90 degrees in it. And then I also am going to think of an acute triangle where everything is less than 90. And something about that seems a little bit weird, because how do I draw a triangle that has a 90 in it, but I actually can't have a 90? It has to be less than 90, but then it's no longer 90. So the question is, can you even draw this triangle? And the answer is, you can't draw this triangle. This is one of those questions that we said at the beginning. If possible, draw that, and this is one that's not possible. And notice that both of those vocabulary words in that question were dealing with angles, and you can't actually draw a triangle that has two angle words in it. So over here on the side it says, can a triangle be classified by two angle names or two side names? And the answer is no, you cannot. You cannot draw a scalene isosceles triangle, and you cannot draw a right acute triangle. You can't have two different names. All right, let's jump to page 2 and work on our equations. All right, in these practice problems, we are going to find triangle angles. And so let's read our directions here. It does say set up equations that can be used to find out the value of x. Explain the reason for each equation. So in these problems, we have to do two things. We need to set up and we need to explain. So in the first question, the first thing that I look at is where all of the where all of the angles are. And in the first one, I notice that I have an arrow pointing there, and I have an arrow pointing there, and I have an arrow just an X right there. And I notice that all of those yellow dots are inside of the triangle, which means those are all interior angles. And I know then that those angles have to all add up to 180 degrees. So I'm going to write x plus 1, x plus 1, plus x plus 5 equals 180 degrees. If you want to do a little mental math, you can add all of the x's together. 1x, 1x, and 1x make 3x. And then plus 1 plus 5 is 6. That also would be an acceptable answer, a little bit shorter. And the reason that we can do that is interior angles equal 180 degrees. If I look at question B, I notice that the angles, I have these two guys on the inside, but then I notice that the third thing is on the outside. This is an exterior rule. And when we do that exterior angle rule, remember these two guys have to add up to be the outside angle. So we have the x plus the 70 on the outside equal to, the inside equal to the outside, the 2x minus 5. There's your setup. That's all that we have to do there. Let me stop right there and I will move down. For question C, the one thing that I notice is that I have the 2x there, I have the x minus 6, and I have the 90. That's the only places that I have my angles. And I do notice that they're all on the inside. So interior angles equal 180 degrees. And so I'm just going to add those all up. Now the real one question that you might have is, what does that box mean again in the corner? And remember, that always means 90 degrees. So before you can do any work, you have to remember that that's 90. And we're going to just write our equation. 2x plus x minus 6 plus 90 equals 180 degrees. Remember, if you want to do a little mental math, you can take the 2x and the 1x and make 3x. And then you can take the 90 minus 6, which is 84, and equal that to 180. Also an acceptable answer. I'm going to pause right here and let you set up D, and then we will come back and see how you did. All right, for D, notice that all of the angles are highlighted on the inside. So the one thing that we notice is that we are going to use the interior angles equal 180 degrees. And so I'm going to add up all of those angles. So the equation that you could have set up was x plus 3x plus 56 equals 180. The left side of that equation can all be in different order. It doesn't matter as long as they're all on the left. And then if you did a little mental math, you might have even written 4x plus 56 equals 180. But there's your setup for that one. I'm going to pause right here. I want you to try E and F, and we will get back to you and see how you did. All right, for E, notice that I have highlighted the green ones. Those are on the inside, and the yellow one is on the outside. So for this question, we did the exterior rule, and that exterior rule is where you add the two on the inside and equal it to the outside angle right there. So that equation looks something like that. 3x plus 40 equals 5x minus 10. And then on question F, we got a couple things going on here. Notice that we have two angles on the inside and one angle on the outside. And if you notice, these two angles right here actually make a linear pair. So I do know that a linear pair equals 180 degrees. And so I can say x plus 60 equals 180. But then if you were going to try to use the other rules that we have, you actually can use the exterior angle rule. And remember that that rule says that these two angles equal this angle right here. So you may not have thought of that, but we can use that. And the real question is, there's no number here. What could it be? And remember that we have 180 degrees in a triangle. So if we have 90 on the top and 60 right here, I know that 90 plus 60 equals 150. And actually, I'm going to slide that calculation right down here. And then 180 minus 150 equals 30 degrees. So this guy right here is 30 degrees. If I use the exterior rule, I actually have 30 plus 90 equals x. So there are two ways to do that problem. Double check your work, see what you were thinking, and make any adjustments that you need to. Now you can jump into your homework, try some of those examples, and we will see you tomorrow in class.